So, so you were seeing the singly linked list. So singly linked list, you were having a n number of nodes. So n number of nodes are linked to each other. Whereas the first node will have two fields. So each and every node will have two fields, but first node in the first field we'll be having the data or the information, and the second field will contain is a pointer will contain the address of the next node. So pointer contains the address of the next node. Okay, so now you come for the inserting the node in single linked list. So there are various operations in single linked list. So insertion, deletion, next you go with searching, sorting, reversal. So these are the reverse operation. So these are the stringly linked list operations. So linked list operations are insertion, deletion, search, sort. Okay, so last one is reversal. So in that we are in today's class we are going with a first operation, that is inserting the node in the singly linked list. What is SLL? SLL stands for singly linked list. Okay, so there are three cases here. So first one is insertion at the beginning, second one insertion at the end, and third one insertion at the particular node. So insertion in middle, you can take it as insertion in the middle. So there are three cases. First one is insertion at beginning, insertion at the end, and insertion at a particular node. So now we shall go with each one in today's class. So each one is you are inserting at the beginning. If you are inserting at the beginning, what are all the cases you need to do? So that means you are creating the first node. So what you are doing, you are creating a first node, and that first node should consist of what? One is the information, that is the data field. The other one is the pointer field. So if you are inserting at the beginning, so what should be done? So the pointer field should follow the should point towards the first node, the next pointer of the node you are creating. So what is that pointer called? Pointer is called as a next pointer. So next pointer should point towards the first node of the list. So keep that one in your mind. If you are inserting a node at the beginning, so if you are inserting, what the next pointer should point, it should point to the first node in the list. Okay, so keep that one in your mind. These are the two steps. So first one is make the next pointer of the node. So next pointer of the newly inserting node. So keep in your mind, this one is, so you take it as next pointer of which newly inserting node point towards first node of the list. It should point where? It should point towards the first node of the list. Okay, so next you have the start pointer. So from where you have to start? So as you are inserting in at the beginning, make the start pointer point towards the new node. So start will be the pointer, you should point towards the new node. Okay, if the list is empty, simply make the start point towards the new node. So here you can see here. Okay, this is nothing. This is not a node. Okay, no, first node, if you are inserting at the beginning, this is the new node. See here, this is the new node. So already in the list, so many nodes are there. So node number 1, node number 2, this is the last node. Okay, now you are going to insert to beginning. If you are inserting to the beginning, that is the new node. So what you should get? So this one is called as a start node. So start, it is now the start node is pointing to where? The start node is pointing to 3 because 2 is not yet inserted. So this is the start node. So what I have given here, head. What I have given here, head, this is called as a start. So initially, before inserting this particular node, so start node is pointing to where? It is pointing to 3. If you are inserting as the first node, if 2 is been placed before 3. So what the head should point? It should point to the first node. So keep this one in your mind. Very, very important concept. So head is this is a pointer. Okay. So it is similar to start pointer. So start pointer, before you insert this particular node, that is 2, it will be pointing to where? It will point to 3 only. Okay. But when you are going to place this node before 3, what it should point? It should point to the node 2. So because this is a start node, understanding? So this start node, we consider it as, now initially the start node is, it is start node is pointing to 3. Now you have to make it to point to the 2. That is the case. So dotted lines are initially. So once you place this 2 here, this is a start node. We should point to 2, and the next field should point to. So next field of the new node should point to the this node 2. So this the new node will become under start node, and 3 will becomes the next node. This one will become node 1, this one will become node 2. So but before you insert this new node, this one will be node 1 only. Understand? Are you understanding? Are you getting? So I will be telling again and again, kindly check it here. So this head, what we consider, it is called as a start pointer. Okay, before you insert a new node, the start pointer, it will point to where? It will point to 3 only. This is before you insert this new node, this one will be node 1, node 2, and this one will be last node. Okay, so where the start pointer is pointing to, it is pointing to the node 3. Okay, but if you are going to insert a new node at the beginning, where the start node should point to, the start pointer should point to the new node. Keep that one in your mind. When you are inserting a new node at the beginning, what should be done? The start pointer should point to the new node, and the next field should contain the address of the node 1. So this one is node 1, this one is node 2, this one is node new. So take it as node new. So node new next field should contain the address of node 1. When this one will become node 1, it becomes node 2. So node 1 will have the data 2, and node 1 dot next will contain the address of node 2. Understanding? Kindly respond. Okay, so now you come for the programming part. So under programming, how you write the function. Okay, so here we are calling a function in. So you are inserting, what you are doing? You are inserting a new node P. Okay. So first initially if there is nothing in the list. So what we take? We take it as a start is a pointer. So start is equal to null. So this happens if the list is empty. At that time, start is equal to P. If there is no list. So what you will do, so that we consider it as this P will be the start. Okay, but in our scenario already there are so many list is there. So in that list you are inserting a node. So first you come for the concept. If there is nothing, no list is there, if no list is there, the start will be null. So at that time you are pointing start is equal to P. So that means node inserted successfully at the beginning. Okay, so this will happen if there is no list. Okay, so if the list is there, so what you will be doing, so at that time you see we are taking a temporary. So temporary means which is the temporary one you are having. So it is node number 3. So node number 3 will be marked as temporary. So for that one you are inserting. So temp is equal to start. Okay. So temp is equal to start means you are going to mark that one as a temporary. So which is the temporary node? So this one is the temporary node. To what you are not yet placed that one we consider it as temporary node. So temp is equal to start, and next you give it as start is equal to P. So temporarily, so where is the start? Start is considered as head. So this is the start. Start is been considered, it is pointing to. So what? It is a temporary. Okay. So first you see, so start is equal to temp. So because you are assigning the start as the temp, so which is the start here? So it is a start pointer. It is pointing to where? It is pointing to the node 3. So initially it is pointing to the node 3. That's why we give it as temp is equal to start. So this is a temporary node. Actually, this one is the start node for us, new node. Okay. So for that one, we are taking temp is equal to start. Okay. So that means it is the dotted line. Okay. So temp is equal to start. Next, you are making start is equal to P. So where is the P? What is the new node you are taking? Start is equal to P. It should point to the new node. So new node is considered as P here. So keep that one in your mind. So start is equal to, first you will write it as what you write, temp is equal to start. So that will mark you which line? This line, temp is equal to start. Okay, so temporary, this one is temporary, that is it has been assigned to start. So after that, now you make start is equal to P. That means which is the P node. So here it is node P. So node P means new node you are going to insert. This is the node P, and that one is been marked with start. So start is now pointing to P. So that we give it as start is equal to P. Okay. Next, what the next should contain? Next, you have to mark this line. So for this is the first line. This is the second line. This one is the third line. So P then next should point to temp. Okay, so this is a temporary because it is a temporary node you have taken. So first initially start is equal to temp. Next you make start is equal to P, and P then next is equal to, it is pointing to where? It contains the address of this node. So P then next is equal to, this is the temporary node. So keep that one in your mind. This is the start node. This is the new node P. This one is the temporary node. First initially you have to mark this one. That's why we give it as temp is equal to start. Next you give it as start is equal to P, and third one is P then next is equal to temp. This is the scenario. So first you assign node, that is node 2, that is becomes the temp is equal to start. Now make start is equal to node 1, and node 1 then next should point to temp only. So that's this is the reason. So are you getting? Respond here. If you didn't understand, kindly respond so that I will explain again, because this is a very, very important concept. So, understood? So there are 54 participants, but no one is responding. If you shall I explain the thing in Kannada if you didn't understand, because it's very, very important. Okay, so I will explain it again, because some are telling it to explain it again. Okay, so first you see this one, go for this diagram. Okay, so initially this one you consider it a start. Okay, so before you insert the new node, where the start will point, it will point to the this one. This one is the node 1. Node 1, node 2, node n. So the first initially start, if there is start will point to node 1. So node 1, we take it as temporary now. Okay, because you are inserting a new node at the beginning. So this one will be considered as temporary node. This one will be considered as start, and this one will be considered as node P. So artha madkoli, this is the start. This one will be start. This one will be node P. This one will be temporary. Okay, if there is no list, so if there is no new list, what will happen? You have to mark. So come for this diagram. So this diagram will tell you again. So first initially what the start will point to. So this one is temporary variable. This one is the temporary node. This one is the new node P, and this one is a start pointer. Before you insert this one, so start pointer will point to where? Temp. So that's why we have given it as temp is equal to start. So this one is temporary for now. Okay, it can be node 1, but it is temporary for now. So this is temporary. So initially start will point to temporary. But when you insert a new node, where the start should point? It should point to the node P. So it should point to the node P, and what the P dot next should point. So P dot next should point to the temp. So this is the 3 steps you can easily understand. So I will tell you again. So kindly check it here. So first start will point to temp, and next start will point to node P, and next P dot next will point to temp. These are the 3 steps you have to carry out. So same thing I will be explaining it here. So you are inserting, what is the function name? It is inserting at the beginning the node P. Okay, so if there is no list, if there is no list, what you will do? So the start will be pointing to null. If there is no list, the start will be pointing to null. At that time, assign start is equal to P. That means if there is no node in the list, what you will do? So you will make start double equals null. Okay, so then assign start is equal to P. So this happens if there is no linked list. If the list is there, what you will do? So if the list is there, initially start will be pointing to temp, and then you have to make start to point to P and assign P, then next is equal to temp. So these 3 are nothing but these 3. So first one, temp is equal to start is equal to P, this one is the next field. P the next is equal to, this becomes temp. Understood? So this is the insertion at the beginning. So now you come for the insertion at the end. So it is very, very easy. If you are making the insertion at the end, what you have to do? Simply need to make the next pointer of the last node point to the new node. So it is very, very easy. The next pointer. So next pointer of the last node will be pointing to where? It will be pointing to the next pointer of the last node will point to the new node. So that is insertion at the end. Okay. So for that you go with this code. So coming for the code, it is same. So initially if there is no list, assign it to P. Okay. If the list is already there, now you see here, while Q then link not equal to null. Okay. So Q means Q then link not equal to null, assign Q is equal to Q then link, and Q then next is equal to P. What is P? It is the new node what you are creating. Okay. So if Q then link not equal to null means, okay, you have to think the last node, the link, next pointer link will be pointing to where? It will be always null. Okay. If Q then link is not equal to null, what you will do? Assign Q is equal to Q then link and then make Q then next is equal to P. So what is Q then next is equal to P? This is the Q. Okay. Q then next should point to this is the P, node P. So if you are inserting the new node at the last, so last node in the next pointer, look point madbeko, it should point to the node P. So this one is the node P and this one is the node Q. So Q then link, this is the link part. Q then link not equal to null, assign Q is equal to Q then link. So if it is not null, you should make it. If it is not null, so what you should make? Assign Q then next is equal to P. This is the node number Q. This one is the node number P. So if it is not null, what you will do? Assign Q then next is equal to P. This is the scenario. So first part will remain same. So if there is no list, so initially the assign start is equal to P, node inserted successfully. If already list is there and you are inserting a new one, so what you will do? So you Q then link not equal to null, assign a Q link for that and make that link should point to the next new node what you have inserted. Okay. So now you come for the inserting at the middle. So how you insert at the middle? So for that you have to go with the 2 steps. So go with the previous node and you are inserting in the middle. So on left there is a node, on right also there is a node. So what you have to make, so that are the 2 steps here. So make the next pointer of the node to be inserted, point to the next node of the node, after which you want to insert the node. Okay. So indinda baradunu, it should point to the new node and new node should point to the next pointer. So that we can see here. So see it here. First initially what is there? This one is node 1, node 2, node 10 it can be. Okay. So node 1 is node 1 dot next is containing the address of node 2. Okay. So if you are inserting in middle, so this one is node 1, node 2, node 3. Okay. So if you are inserting in middle, first initially what will be there? Node 1 dot next is equal to node 2. Okay. So if you are inserting in middle, this one happens to be node 2. So node 1 dot next should contain node 2. Node 2 dot next should contain node 3. So that is the concept. So here you can see. Okay. So first insert after. So if you are inserting at one particular location, what is this C? C tells it is a location, whether you are inserting at location 1, location 2 or location 3. Okay, so if you are inserting at the middle, that we consider it as C, and at one particular location, that is considered as C. So what is this C? So C is nothing but location. So location, you are inserting a node P. So initially, if you are inserting in middle, so already on left there should be list should be there. Okay, list irle beko. So because you are inserting in middle, okay, so there is no condition for checking null and all. List is empty, nothing will come because already the list is there, and for that you are inserting in middle. Okay, so first you make q is equal to start. So start from location first node 1 up to node n. So it can be node n. So I am telling you location int c means location. Location means it can be between 1 and 2. It can be between node 2 and node 3. It can be between node 3 and node 4. That is the location. So first initially q is equal to q then link. Okay. If q double equals null, so that means you are not supposed to insert. Okay, if not, okay, if the number of nodes that are already present, maximum number of the nodes are already present, then this one will come to the act. If the maximum number of nodes are already present, this one will come to an act. That is q double equals null, that is less than c nodes in the list. Okay, so at that time, now you spawn to this two steps. Okay, so P then link is equal to Q then link. Can you tell which link it is? P then link is equal to Q then link. So here you can take P then link should, here you see here. So P then link is equal to Q then link. P then link is equal to Q then link. So next you have Q then link is equal to P. So Q then link is equal to, this is the node P, this one is node Q. Okay, so first you can write it as node Q. Okay, this one is node P. Q then link is equal to P, and P then link is equal to Q then link. Okay, so that one you can take it like this. So these are the two steps what you have to do. Okay, so P then link is equal to Q then link, and next you can have Q then link is equal to P. Okay, these are the two steps, or you can go with the three steps also. So which are the two or three steps you have? So first, this one is node P, this one is node Q. So what you should have, Q then link is equal to P, and P then link is equal to this one also, you are marking it as Q only. So Q then link is equal to P, and P then link is equal to Q. So these are the two steps what we take for the insertion. Have you people understood? So kindly go with the diagrams. So if you go with the diagrams, you can easily understand the concept. Okay. Okay, this is up to insertion operations. So in tomorrow's class, we shall go with a deletion in single linked list. Okay, so I hope you people have got understood. If not, you can go, I will be upload that particular thing in my YouTube channel. So this is my YouTube channel ID. So kindly subscribe, and there you can see the videos. Okay. So here I will be ending my particular lectures. So thank you all.